welcome. I'm glad to see all of you here. I will give you a little bit of background about myself, and then I'm going to get into the talk. So I'm Mathis. I'm lead product manager at deepset. I've been working as a PM for a few years now, either on more traditional web development products, but also on many products that had NLP at its core or some NLP functionalities. And I've also worked as an NLP engineer here at deepset, where I help many clients implement NLP solutions for their products. And during this time, I've seen many ways to build NLP applications. I've tried it myself with many different teams, and I've seen it work sometimes, and sometimes I didn't see it work. And over time, I realized that there's some patterns actually that make teams successful, that made me more successful as well. And this is what I want to share with you basically today here. And nothing that I'm telling you now is anything like really new or revolutionary. Basically, it's what we know from traditional software development for like at least 15 or 20 years now. It's like iterate fast, get feedback, ship early, ship often. So many of the best practices that got introduced to software development with like frameworks like Scrum or Agile in general, Lean maybe. But when it comes to NLP, we kind of have seemed to have forgotten about the lessons we learned in the past. And this is what I want to talk about today. So we're going to do that by building an example NLP application together, just on the slides, not in real life. And then we're going to build it two ways. We're going to build it the way that almost everyone else does. And then we're building it like a product team would. And in the end, we're going to talk about some learnings and what we can actually gather from that. Okay. All right. So let's start building this application. What we want to build today is a searchable knowledge base for 10K or annual reports, so company reports, that helps business analysts in an investment bank's mergers and acquisition department to find and rank potential acquisition targets for profiles that their clients shared with them. So they have clients that are looking to merge or acquire a company, and they have like an ideal profile or companies they like. And they are asking the analysts to find more companies like that in a knowledge base. And this product is better than Bloomberg's global company data because it uses semantic search under the hood. So in this last sentence, you have that NLP part of the product. So it's a full product. NLP plays a role, and it is actually part of its core value proposition. All right. We've also assembled a team to get this done. We're in a big investment bank somewhere in the US, maybe. We have a product manager who works in the internal tools department, so producing tools that other people in the bank will use. We have an MLOps engineer, and then we have 2 data scientists on the team. All right. So let's get started building. We have a project kickoff where the product manager comes to their team. They tell them, hey, we have this new project, and what we want to do is we want to build semantic search on financial data. And the team, naturally, because it's a new project, it's new data, they're excited. The MLOps engineer really wants to apply all the best practices they have learned about in the last years and that I've seen also. they want to build this full production pipeline where everything you can automate is automated. You have automatic retraining on feedback, you have shadow model serving, like everything that you could wish for. And then the data scientists haven't worked with NLP that much before. Usually they work on numerical data because they're in a bank. But they've heard about these dense vector embeddings, so way to compare texts in vector space. And they're really excited. They say, yeah, let's get started. We just need training data and then we can get going. And that's what they do, actually. They go and start building this product or this service. And what they start with is some exploratory data analysis where they try to find out how much data they have, what data, how it's structured, what formats it comes in. And after that, they do quite a bit of data cleaning because the annual reports come in PDF formats. They have tables in there, they have infographics, and to actually run NLP on this, they need to extract the texts, and this should be clean text, and just extracting from the PDF documents doesn't produce the results they want. So they implement some quite complex pre-processing pipeline. And after 4 weeks, they're done with all the initial explorations and data cleaning, and then they want to start generating the training data. And they sit together and talk about the task first, like what will people annotate. And because they want to identify similar texts, they decide that they will show the annotators 2 passages, and the annotators then should decide whether these passages are similar or not similar. So very easy task, but they still take some time to really prepare an annotation guideline and make sure that all their quality standards are met. And because they think they're going to need like maybe 10 to 15K training samples to really train a model that will work, they actually decide to go with some click workers who do the annotations because they couldn't do it. And also the business analysts don't have the time to actually annotate like 10 or 15K samples. So they set up this whole test set to qualify click workers, maybe on Mechanical Turk or some other platform. And they do the annotations in a few iterations to keep the quality high. And that naturally takes some time. Annotating the data is always a very important part of your process, so you should allocate the time. And after 10 weeks, they've got the data they need and they're happy. And then they iterate over a few models. They try out a few approaches to the problem. First, they try DPR, dense passage retriever, where you have one model encoding the question and then, or query, in their case, a company profile, and then another model encoding the target. In this case, it's passages from the annual reports about the companies. And they also try an approach that is called retrieve and re-rank, where you use some standard technology like BN25, so what you got in Elasticsearch or OpenSearch, to retrieve a larger amount of passages. And then they re-rank that using a transformer model. And the third thing they try out on their data a little bit is a sentence transformers model. So a simple embedding encoder that just transforms both the query and the target into vectors, and then uses a distance metric like cosine similarity or dot product to compare the 2 texts. And they, in the end, they decide for the sentence transformers model because it's easy to train. It works better than DPR, and it's less runtime intensive than the retrieve and re-rank approach. So they choose that. And then they start training the model and evaluate it again and again. So they took a small part of their data and use it as an evaluation set. And they try to really optimize some metrics. They try to optimize recall, of course. So how many passages that were annotated as similar are actually predicted as similar by the model. And then they also look at some other metrics and really try to optimize and find the best model, iterate over a few hyperparameters, just learning rate, batch size, and so on, to get the optimal model. And in the end, they're quite happy. They saw a big improvement from training. And after 14 weeks, they handed over to the MLOps engineer, who then does the full production setup. So what they do is they set up the data pipeline that performs all the pre-processing that they've implemented. So what happens is that many new reports come in every day or every few weeks or something, and these new reports also should be pre-processed. And what the data scientists implemented was like in a notebook or somewhere, so it needs to be in a proper pipeline that runs stable in production. And then they also implement the whole thing that should serve the model to the users. So an API that receives queries and then goes and looks up matching documents from the database. And they also do it in a way that people can give feedback on their results, and then this feedback is used to automatically retrain the model every few weeks. And this whole setup naturally takes some more time, but in the end, they're quite happy. And after 18 weeks, they say, all right, we've finished our product. Here's our new NLP service that performs semantic search on annual reports. And now they actually want to go to the customer and show them what they've implemented. But because the application development team is still struggling and they don't have an interface yet, what they actually do to get user feedback is they have a Slack channel, and then they ask like everyone involved in the project to kind of come up with their favorite queries. So something where the model really produced very good results, where you can really see the semantic capabilities of the model. And they assemble these queries and examples into a spreadsheet and send that over to the analysts so that they can get feedback on these samples. And the analysts actually, they don't really know what to make of this. So they look at the queries and they're like, well, that's not something that we would ask during our daily work. It's not really relevant. It's too trivial, and it doesn't really apply to what we do. So what should we make of this? And then the team who built this is a bit frustrated, and they try to explain that, of course, it's not exactly the same, but this model is able to generalize actually, and it will capture their language as well and their queries, and then give the right predictions. And they also say that they have all this complex retraining logic, and that actually it will learn in production. So they shouldn't worry too much about about it now. And then what they do is they convince them to move to production, and they do. And then what the outcome is there's no improvement from feedback. Actually, they run it for a few weeks, maybe a month in production. They get a few thousand feedback points, but the model doesn't improve after training from that. The analysts really don't like the results, and they stop using it at some point. And then the product is declared dead, and no one in that company wants to touch NLP ever again. And that's quite sad, because actually NLP could have helped them in many cases, but they just made this like bad experience and said, well, it seems like machine learning and AI and NLP is just not up to the task, and it's too complex. We've tried that and it doesn't work. All right. So now, second try, we're building it like a product team. The term product team, I think it comes from, it's quite old. I think it comes from Marty Kagan, or he has popularized it at least. It means that you have a team of experts, but they work together as a cross-functional team to deliver a product, and they as a team have ownership of that product. And they are empowered to take the decisions that they think are needed to really produce the results that some customer or client wants and that delivers value to them. And it's the same team, but the mindset shifts. So we also have, in this case, our PM, we have an ML ops engineer, and we have 2 data scientists. And in this case, the kickoff goes like this. They meet all together with a few business analysts and really want to understand the use case. So the business analysts tell them, yeah, we have these customers that send company profiles, and we need to find matching profiles and annual reports that would interest these clients. And then the product team asks questions and really tries to understand that from every angle. And if you do a kickoff meeting like that or early in the project, try to get example data beforehand, because usually that really helps understanding the problem and asking more relevant questions. So what they actually did is they asked for a few sample profiles that these analysts got from their clients, and then also what they would match to these profiles. Just a few samples, nothing to like evaluate or train on, just to understand the use case. And then equally, they go and they start building this NLP application. And naturally, they also start with some exploratory data analysis to understand what data they have. And then the whole team actually assembles and builds a prototype. And what they do is they use an off-the-shelf model, so a model that was already trained on the semantic search, semantic similarity task, but they didn't train it themselves, and it's not trained on their domain-specific data. And they use something like Streamlit UI to build a simple UI, and the ML ops engineer uses a framework to just quickly spin up an API that can serve that UI and serve the model and really work like an interactive prototype where an analyst could then like search something and they get back real results from their data. Although it's not adapted to their domain, it still works the same as the end product would. And they also implement logging for the queries that analysts put in. So they have like the profiles that analysts would ask for afterwards. And they also implement an easy feedback mechanism, something like thumbs up, thumbs down, where they can see if an analyst liked the result or not. And after 4 weeks, they've built that prototype and they give it to the business analysts, and they say to them, well, just start searching, start using this the same way you would use it during your daily work, and give feedback on the results. And then over the next two weeks, the analysts search and use that prototype, and the product team actually analyzes that feedback and really looks into what type of queries do we get, where does the model perform well, and where does it not do so good. And after 6 weeks, they're quite confident that they've really understood the problem and the domain. And then they ask the analysts to annotate a small evaluation set, just like 200 to 300 samples that they want to use to quickly benchmark new pipelines that they implement. So whenever they change like pre-processing or model, they don't have to do this whole feedback cycle again. They can quickly iterate on the evaluation set. And the analysts are quite happy to do it, because they actually saw already the potential while using the prototype, and 200 to 300 samples is very easy. It's like 2 hours for like 3 or 4 people. So they do that. And after 8 weeks, they have an evaluation set in place. And then they try and switch out a few components of their retrieval pipeline. So they have a model, they have pre-processing, And of course, they can switch out all these components. And what they actually find out is that if they use a pre-trained sentence transformer model, let's say all MPNet base that works on everything from my experience. So they use that and they mix it with a sparse retriever, something like BM25, and then join the results. So hybrid retrieval. I think maybe you've heard of it. It's I don't know, Pinecone, for example, has just implemented something like that for their vector database, and it works quite well to actually adapt models to domains, or not really adapt the model, but to balance out the deficiencies on a model if you have very domain specific data. And they identify during the evaluations that this pipeline performs best. And then they actually give that pipeline back to the business analysts. They update the prototype using that new pipeline. And the business analysts start using it. And they're so happy that they see they really start using it for their daily work. And they don't want to stop, basically. And then what they do is they struggle a little bit because it doesn't scale. It's quite slow sometimes, a bit buggy interface wise. So they really try to improve that and stabilize it a little bit. But basically that's in production. People are using it and they make iterative improvements afterwards. And here you can see like how they collected feedback. This is a more advanced interface, maybe something very simple would do as well. For example, our open source framework Haystack comes with like a REST API and a demo UI built with Streamlit, and there you can also give feedback, and it really works as an end-to-end prototype. So what are the outcomes here? The analysts love the prototype and they save a lot of time using it, and soon they want to tackle the new NLP use case that is waiting just around the corner. So we've seen two ways of doing this, and what I want to highlight here is that both teams made good decisions, but one team basically failed to get early feedback. And this is what I learned again and again. Like you saw in the timelines, that's a bit artificial. Like one team was a bit faster than the other, but in the end, what it comes down to is that one team has to basically start from scratch, or what they build will never be used, and the other team actually delivered something. So that's where you save time and actually have also the advantage of having something in production. So this is my number one point that I want to make. You should talk to your users. It sounds very simple, and it is actually. Just talk to them, do interviews, just have an informal chat, do surveys, whatever works, but definitely talk to your users. And many people say like, yeah, but we don't have any users and there's no one we can talk to. I'd say there's always a way. For example, if you're like in a B2B company, B2B SaaS, or you develop something for an internal business line, in a B2B case, you have a sales team, they have like contact to users every single day. Just go to them, ask them, how can I get in touch with actual users or potential users? Ask the marketing team to run a campaign with you where you announce some user testing and try to get participants, but really talk to your users. And then when you do a specific project or product, really get in user feedback as early as possible. If you can get something up and running to get feedback on in a few days, then great, do that. If it takes a few weeks, all right, but it shouldn't take anything like 3 months. That's just too much time spent in uncertainty whether you're really delivering the thing that is needed. When getting feedback, use an end-to-end prototype, meaning that it should be pretty similar to the end product, and it should also be on the data that will actually be used. Sometimes you might need to use a subset of the data, which is fine, but you shouldn't use like totally unrelated data or data that will never be used in production. What you should also do is you should use off-the-shelf models, meaning that in NLP we have transformers, and transformers basically get you to 80% of what you need. And it's really hard to get from 80% to like 83 or 84 or 85, which would be sufficient for production usually. But whenever you approach a new task, you're gonna find fine-tuned models that already work for your task. They're not adapted to your domain, but they can demonstrate what a NLP application would do. So just don't worry about the training, use something, go to the Hugging Face Hub, find a model that performs best on your task on general data, and then use that for the first prototype. Again, get feedback. So don't stop like at the first point when you had the first prototype and got feedback on that. Do it again and again. And whenever you spend too much time developing without feedback, you run at the risk of doing the wrong thing or going into the wrong direction. So really get feedback again and again. And then what you want to do before thinking about any training data, annotate a high quality and evaluation set. And I really want to stress this high quality because in this case, for example, we have business analysts that are trained for years to perform the work that they do. And then the first team got click workers to annotate something that they would benchmark the solution against. And these click workers didn't have the training or the expertise. So how should a model that is benchmarked on this data be better or be suitable for the task that the business analysts actually try to perform? You can train on noisy data. There's many ways, but if your evaluation set isn't clean, you're essentially flying blind. So really you should have a very high quality evaluation set, and you should get subject matter experts to do the annotations here. Just for the evaluation set, training set, data can be messier, but evaluation set should be very clean and of the highest quality. And now I want to talk a little bit about the tools you need to work this way. First of all, you need modular pipelines, some framework or abstraction that allows you to easily exchange components and models. For example, exchange the pre-processing, exchange the model in a pipeline, add a different model. And there's many solutions out there, I think. Hugging Face pipelines is one of them where you can easily exchange the model. And then, for example, Haystack pipelines is a more end-to-end solution where you actually have the pre-processing and the document store and everything in there as well. And it's designed in a way that it's very easy to make changes. And you will need that to rapidly iterate over different prototypes. You also need a way to quickly deploy a pipeline, including a UI to gather feedback. I think modern cloud infrastructure has come a long way. So I don't know, deploy something on SageMaker or EC2 somewhere. And if you have like an MLOps person or someone with some experience there on the team, you're gonna succeed. And for the UI part, just pick Streamlit, pick Radio. Maybe there's something that is pre-made. Just something that works and that transports like how the application would work in the end. It doesn't have to be pretty, it just has to work somehow. You also need a way to track feedback. Explicit feedback is good, but more important is actually also implicit feedback, not even feedback, like basically what people search for if you do a search application. Because actually seeing, like listening to people and asking them about their behavior and expectations is one thing, but oftentimes their view on what they need differs from what they actually need. So you also need to verify using data like that you collect during user testing. Another thing you need is good tools to actually look at this data and do qualitative data analysis. And here I think the market is really, there's not much out there. Like you have all these experiment tracking tools, like, I don't know, weights and biases or MLflow, which provide you with metrics. But actually looking at individual predictions or at queries that a user issued and really digging deep is important, because we're dealing with language. Humans are quite good at languages. We're not that good at numbers, but languages we do quite well. And we can actually look at text data, identify patterns, and then extrapolate from there. And that's very powerful. So you should be able to look at the data and analyze it, tag it, make notes, stuff like that. You will need an annotation tool. It depends on your task. There's many annotation tools out there. There's free open source, free hosted, paid hosted. Pick something that works for you. It shouldn't be in the way, and your users should be able to annotate quickly, but it's not essential to the project what tool you choose in the end, I think. And then oh yeah, then what you want to do is you want to have a way to actually track your experiments, like the more systematic ones you run. So what you, I don't know, maybe you want to have something like weights and biases where you automatically log all the results, all the metrics, you have everything in one place so that it doesn't get lost in the process, because it can really slow you down if you have like bad housekeeping there, and then you have a few results flying around on some server and you don't know which model actually produced that, and you have to rerun experiments again and again. Yeah, but that's basically what I think you need to succeed in shipping NLP applications to production fast. And with that, we can go to the Q&A session.
Absolutely. Yeah. We can, yeah, absolutely. We can stop sharing. So we have some awesome questions here. The first one, surprisingly, it's also from someone called Mathis. So Mathis asked, do you think training custom models will be necessary for common business tasks in 3 years? Or will LLMs like GPT-3 replace this pipeline? Why isn't there any big open source LLM yet? And why hasn't Google released an LLM API? So it's a long question. So
yeah, okay. So there's multiple questions in there. I'll try and answer all of them. So first of all, will you need to train models on common business tasks in three years? I think that right now, even for some tasks, LLMs are already sufficient out of the box. So for some tasks, you don't want to train anymore, except that it's still very expensive to run an LLM or to use an API. And you can get many of the benefits with some fine tuning. So for example, for question answering models, we've benchmarked like our fine-tuned debirder models that were trained on Squad against GPT-3. And of course, the models that were trained on Squad performed much better, but actually it's not expensive to train that, but it's much cheaper to run. So that's a trade-off you have right now. Maybe you have efficiency gains in the future. Then you might not do this step anymore, but I really don't know. That's hard to say. So big open source LLMs, I think there are a few. I think there's like OPT from Facebook or Meta. There's Bloom from Hugging Face. And then Google actually open sourced, I think it's called ULB2, which is quite nice. If you're interested, you should take a look, or it looks nice. I want to take a look because it has only like 20 billion parameters and might be a bit easier to handle. And then why has Google not an LLM API? I don't know. You have to ask them. Maybe that's not their business model, basically.
Yeah, so we have another question which says, how much data is good to have when we retrain the model for a specific domain?
That really depends, like, from what checkpoint you're starting. Like if, for example, if the model is already trained on the task and the data is close to your domain, you need less data than when it's not fine-tuned at all, or when it's very far from, like, the training data it saw is very far from your domain. Specific numbers are hard. I think usually what we see is that you definitely, I don't know, need below 10K samples, usually for things like question answering or semantic search. For things like NER, you will need some more samples, I think. But something like we have success with 1,000 samples basically, and sometimes if we go up, of course, it gets a bit better, and especially your model is able to generalize more usually the more training data it sees.
Cool. I have another one now from, it's anonymous as well. So how important is it for the PM, owner, or manager to understand ML, NLP, and at what level do they need to understand this, basically?
Yeah, so I think that really depends on the product you're building. So in my case, for example, with DeepSet Cloud, we're building a product that is actually targeted at machine learning engineers, NLP engineers who are building other NLP products. So in my case, the understanding needs to be quite high. But then also, if you just NLP is just a part of your product, a PM should still understand the basics. They should understand what fine-tuning is, what evaluations are, and they don't need to be able to like implement it on a technical level, but they should understand what is happening.
Got it. I see a lot of questions here about the recording. So just so that everybody knows, we will share the recording afterwards. So don't worry about that. But if you want to ask something live, then just go ahead. And yeah, so now next I have a question from Heiko. And the question is, any good ideas on how to assess LLMs for text generation tasks when there is no labeled data?
I think there's like with text generation, I don't have as much experience with text generation. I think sometimes you might just check for something like grammaticality, or I think there's also some ways to assess like logical consistency if it's a longer text. I think many of the upcoming evaluation metrics are actually going to be model-based, so that you don't have like a rule-based metric, especially for the harder cases, but another model deciding if that is good. Yeah, but hard to say. It's always easier to have labeled data. But then again, for example, for, I don't know, a model that generates summaries, even with labeled data, it's very hard to assess whether this model produced summary is better than the gold standard summary.
Cool. Yeah, I have a question from Matthias next, sorry. Now, suppose that in a project, you're dealing with highly sensitive data subject to regulations. Thus, you cannot use production-like data out of the box. So what would be your approach there? So example, building a synthetic evaluation data set in-house, or any tips from your experience for these kind of projects, right? So sensitive data, basically, right?
Okay, so in the past, I've been on projects where we didn't have access to the data right away or only on some data. So what we tried to do was to find data that is public but in the same domain, and then annotate that data, for example, as an evaluation set. It works, but you still run at the risk of going into the wrong direction. So I'd actually also spend some time really questioning if you cannot use that data at all. Maybe it can be anonymized, at least a subset for evaluations. Maybe you can use a part of the data, maybe like really try to figure out if there's no way. And if there's no way, use data that is as similar as possible, but public.
Correct. There's also an interesting question from Shilpa next. So feedback is something you stress the most in the talk. What are some good ways to include feedback mechanisms, and how do we incorporate the feedback that we gather into the project? I mean, use feedback for annotations or anything else. So yeah.
Okay, so a good way to gather feedback that I've seen is like actually ask the users to perform the tasks that they would envision performing when they had this application. And that's why you need this like end-to-end prototype. During a development phase, I've seen good results with explicit feedback, because you are working with a small group of users that you are in close contact with, and you can actually tell them, please give feedback on like not just the best results, but on multiple results. Also give negative feedback. Like you can really balance it. And if you see that it's very one-sided, you can ask and clarify. In a production setup, you have the issue that you're not as close to your users, so you cannot really understand where some of the feedback is coming from if it's explicit feedback. But then you also have the advantage of more implicit feedback, like, I don't know, click-through rate on a search result or something like that. And you have to use a combination of both, then in production, explicit and implicit, to really incorporate it. And the way how to incorporate it, for example, if you see in your production setup that a certain query always performs like badly because no one clicks on the results, then you can actually find similar samples and let users annotate. So annotators annotate these samples. So you're improving very specifically what the model is bad at. Because if you use feedback like directly, and that's what I hinted at during my talk, like users giving positive feedback for a prediction, for example, this is what the model is already good at. So if it has already ranked this passage on like in the top 10 results, and you basically like reinforce that as positive, the model is not going to learn from that. It's going to learn from the negatives, but you also need positives. So you always need to like do something more with the feedback data to actually train the model on.
Fantastic. So now another anonymous question, unfortunately. So what to do if the data science team doesn't understand the modern app architecture thing? Example, like modern RESTful API. So what do you do then?
I think if this is a significant part of your project or product, you should really get people on the team that do understand that and that can share the knowledge here. If that's not feasible, maybe get someone like a consultant for some time. And I think that most of the times, like with machine learning, NLP engineers, they're quite like modern and want to use the latest things. And I think like the modern application architecture also falls into this camp of modern things. So I think you will not have like a very hard time to actually motivate them to look into this. But I think it's important to understand like a service-oriented architecture and what an NLP service does in the full application.
Fantastic. So one more question, I think, and then we have another follow-up from Mathis. Okay, so let me do the question from Mathis first. Thanks for your previous answer. When you have embedded a big knowledge base and then you have access to a better model, you will have to embed everything again, or are there any ways around that?
I think you will have to embed again. Maybe there's a very complicated mathematical approach to do that, but I'm not sure there is, and I think it would be computationally probably more expensive than just embedding it again. But you shouldn't really be afraid of that. Like I've seen, I don't know, for some customers, we embed like 60 million documents, and depending on how many like cloud workers we run that on, it will take some time, but it's also not too much, doesn't cost too much. And these models, like especially embedding models, they're actually quite small when you compare them to these huge language models, large language models. Might be different if you use like the large Cohere embedding model for your production setup. That could run you quite expensive, or OpenAI. But then again, they don't constantly change their models, so I think you would be fine.
Awesome. So yeah, going back to the anonymous question then. So where do you see the biggest challenges of serving the model to end users, to the end users basically?
I think the challenge usually, or what teams struggle with, is to understand that it's not just serving the model. So what we see is we already have like many solutions, like, I don't know, specialized inference servers like NVIDIA Triton, or even hosted services like Hugging Face Inference API that serve the model. But in the end, what you need is a full pipeline, because you need data that the model has access to, or that the model embeds in the case of a vector search, and then writes to a document store or vector database. You need pre-processing. You need maybe some other model in the pipeline. For example, for question answering, you have a retriever and a reader, so two models. You need to communicate between those two models. And setting this up is quite complex right now, I think. So this is, for example, something that we help people with in DeepSet Cloud, to actually have this whole pipeline easily deployable to production, and also for development purposes.
Got it. So I think one more question, and maybe we'll have time for maybe just one more after this one. So does the app team, like backend and the front end teams, basically, do they have to understand machine learning or NLP? So is that important?
Yeah, I think that some understanding is good. I think especially like with NLP, or in general with machine learning, for example, for a front-end team, there's interfaces that haven't existed before, because it's a different interaction of human and machine that they actually needed to implement. And then also for the backend team, a lot of the tasks that are performed by models, maybe, for example, need to be performed asynchronously, or they have different hardware requirements, which would probably be more relevant than to a DevOps or MLOps engineer. But a bit of understanding of what actually happens there is good, but they don't need to be experts.
Got it. So another question I have was, oh, hold on, I lost something. Yeah. So what are the most common technical use cases of NLP? Can you mention them? Is it more like question answering or semantic search? So basically, what are you folks working on usually? So what are we working on basically more?
Yeah, so I think we are usually working on semantic search, question answering, document similarity, which is similar to semantic search, but instead of a question or query, you have to compare two documents. We also do some information extraction where you can use question answering to get more structured information from documents that always contain the same information but in different forms. Yeah, that's what we work on usually. Some named entity recognition. Yeah.
Cool. Oh, we have another question from Shilpa. Which are some open source vector databases that you could recommend, that you would recommend?
That's very hard to say. I think the vector database market has exploded in the last year or last 2 years. I think what you should do is go to Haystack, plug in like all of the vector databases that exist in there, and try out what works for you, because it really depends on your use case. If you need like the reliability and I don't know, like the whole matureness of Elasticsearch, then use that. If you want something really fast, like Face, then use that. But it really depends on your product or project.
Cool. Okay, so I have one more question that came in, so I think we can still take it. So, what metrics are suitable for the data science team to use when collecting user feedback? Is it F1 or something else?
So F1, usually we would use that for question answering, where it measures the overlap of the predicted answer with the ground truth answer in terms of tokens. For feedback, you probably can't use that because otherwise people would have to actually mark the correct answer. And that's very cumbersome. I think if you can get your users to do that, then great. I'd go into the direction of something very simple, more like accuracy, which I wouldn't use normally, but you have to treat the feedback with a grain of salt. So you cannot say, okay, this metric is going up, so it's definitely a better model. You have to cross-validate with the evaluation set, or maybe with a more structured user test or something. Pick something that works with your data and the feedback you get, but don't rely on that metric only. Always, use a few different metrics.
Got it. I think that's about all the time we have today, for questions. I just have a couple more slides to go through, but thank you so much, Mathis, for sharing all of these insights and for answering all of the questions. For anyone who did not feel like asking a question today, but you still have some, I will send the recording after this by email. So in that, you could just get back to me, just send me your questions, and I'll get in touch with Mathis and see if we can answer some of them. Till then, some other information for you guys. So just thank you for joining this webinar. If you're also interested in doing an open NLP meetup soon, so that's about ethics in natural language processing, and also show you a practical introduction to image retrieval. So that's happening on 1st of December. It's online. You could just go to meetup.com and look for deepset, or you could just scan this code that you see right here. I will also send a link to the meetup in the follow-up email, so that should be fine. And let's continue the conversation. So we are online, so we are available. So please join our Discord channel. There you can chat with Tuana, who has been answering most of your questions today. So we have a dedicated channel for Haystack. We're also available on LinkedIn. So we have like more than 5,000 people following us on LinkedIn. We keep updating like regular stuff about NLP there. And we're also available on Twitter. So please be sure to continue the conversation there. Looking forward to seeing some of you guys again, in our webinars or talking to us on our social platforms. And I think that's it. That was the session for today. Thank you so much to everyone who attended. Thank you for staying till the end. That's even better. And yeah, I think that's all we had for today. And yeah, have a good evening, everyone.
Thanks. Bye.
Thank you. Bye-bye.